today we talk about definite integration with substitution. Now, let's say you get a question like this. This question is most likely going to happen in paper 1, because if this happened in paper 2, then you can simply just use the GDC and then find the answer. Now, if this is paper 1, or this could be a paper 2 that you have to find the exact value, in this case you shouldn't be using the GDC, this is the method that you should be doing. That is, first look at this E, and if this sine x can be substitute away, then my life becomes easier. Obviously, you can do this by inspection as well, but today our emphasis is on substitution, so I'm going to do it step by step using substitution. I'm going to let u to be sine x. Therefore, du dx now is going to give me cosine x. The purpose of this derivative is to be so that I'll be able to substitute away the dx. Therefore, my dx now is equal to du over cosine x. Now, once you can substitute away the dx, the other two things that you need to worry about is this. That is the lower and upper boundary. So now I have to worry about the lower and upper boundary. The lower boundary use 0. That is when sine 0. That's just going to be 0. U of pi over 2 is sine of pi over 2, which is simply 1. Therefore, now my integral can now be written as from 0 to 1. Cosine x, I'm going to write it in as it is without doing anything, because I'm going to do a cancellation with du over cosine x later. Then e raised to the power of u, and dx now is replaced by du over cosine x. And now you can see the cosine x and cosine x can cancel and be left with this. That is, integrate e to the power of u with respect to u from 0 to 1. This is relatively easy because e to the power of u, the integration is itself, and we need to evaluate from 0 to 1. That is e to the power of 1 minus e to the power of 0, which is e minus 1. And here is the answer. All right? Okay, it's not that difficult, right? So let's also go to the next question. Here's the next question. You may want to pause the video and try it out yourself, and then when you're ready, play the video to check the answer. All right. Here we have square root of something. So this is the something that I like to substitute away. So let me say let u equal to 3x plus 2. And then du dx in this case is 3. The purpose of doing the derivative is so that I can substitute away the dx. Therefore, I need to rewrite here dx here is equal to du over 3. So now I can substitute away the dx. Next, just like before, we need to consider the two boundaries. U of 1 and u of 1 is 3 times 1 plus 2. That's going to be 5. And u of 4, in this case, is 3 of 4 plus 2. That's 14. So now we are ready to do the substitution. That is, my new integral will be from 5 to 14, and u to the power of 1/2 and the u over 3. Or rewriting this will be 1/3, bring out the constant, from 5 to 14 of integrating of u to the power of half du. So this one is relatively straightforward. So the answer here is u to the power of 3/2 divided by 3/2, or 2/3, and evaluated from 5 to 14. So now I can write the 2/3 here is a common factor, so it's actually just going to be 2 over 9 out here. U here will be 14 raised to the power of 3/2 minus 5 raised to the power of 3/2. And now, without any calculator, this will be my final answer. If you have a calculator, then you can find that this is roughly equal to 9.163 SF if you have a calculator. So without a calculator, this will be the answer for paper 1. Alright, now we have the third questions here. You may want to try it out yourself first, and once you're ready, play the video again. Right, these we have to use substitution. We cannot use by inspection. So I'm going to let u to be x plus 1, the thing inside the square root, just like usual. And because there's x outside, I also need to replace this x, that is this particular x here. This is x is u minus 1. So once I've done that, now I need to replace the x. So that will be du over dx is equal to 1, or du is exactly equal to dx. Now I need to worry about the boundaries 0 and 3. So u of 0 is 0 plus 1, which is 1. U of 3 is 3 plus 1, which is 4. So my integral, the definite integral now can be rewritten as from 1 to 4, u minus 1, bracket, and then u raised to the power of half du. So opening up the bracket, we will get this u to the power of 3 half minus u to the power of 1 half du. Alright, now we do the integration. So u raised to the power of 5 half times, divided by 5 half, or times 2/5, minus u raised to the power of 3 half divided by 3 half, or multiplied by 2/3. And this is evaluated from 1 to 4. And if you do this thing carefully, you will find that you have 2/5 bracket 4 raised to the power of 5 half minus 2/3 4 raised to the power of 3 half minus 2/5 1 raised to the power of 5 half, which is 1, plus 2/3 1 raised to the power of 3 half, which is exactly 1. So if you've done this calculation correctly, you will find that this is 2/5 of 31 minus 2/3 of 7, which can be simplified to 116 divided by 15. Thank you very much.